Hello, dear users of Proton Elıc. Today we present you with Proton Elıc Doktrin training, part 1 in our video. In our first lesson, we will learn how gaps are evaluated and what signal intercyclids mean. Our total course will consist of 12 lessons. In our first lesson, I will give information about the gaps. We will now open up a series of the data from our original field data from our customers and review them together. Let's examine how the gap is seen and how the signal intensity are evaluated. We open our first check, the shutting jam up. I move my screen to the shutting area with the help of the mouse. As you can see, the 0 point was a good quality shot. Near the middle, good quality shot. When we bring it right about our gap, the depth bar on the left side has gone down to the bottom. This means full space, so when we execute it, we can clearly see that there is a gap in this area. How we understand the signal strength. On the other hand, if there is a gap in questions from our customers, this is a gap. The fact that the signal strength extends down to the outside of the metals is a sign that there is a gap in the area. So no matter how far down it is a total void. In order to understand the carrot dip here, or to understand the distance, we examine the articulates here. The shutting here in this indoor shutting. He scanned across. Note that the values change as you lower it down. Since the air is not a distance unit because it goes out of the range outline. So when we look from the ground, it shows us only its depth. How can we understand the distance from here to use? As you can see here, when I pull down a little bit, the distance cursor is created and distance cursor is out of range. The deep gauge here is the matters, 93 centimeters. We have to calculate it this the way. It gives us the distance from the wall that we hold before use. Whichever the rock is, a greater it is. In fact, this is not in depth. The depth cursor emerges to the surface, so distance is dilated here. The reason for the depth cursor that appear here is because it's facing up or facing up. So this number is distance from to the target to use. Notice that there is a contractions in this part of the blue color. Indicate this part in the end direction. Yes, it stands before use, but we see it horizontally as it pulls from the operator who use it. Because it's above the range outline. The long blue color appears here. All our users can easily Notice this. On the other hand, this gap begins to expand backwards. Actually, it is like a triangle. There seems to be no such room here. In this case, we will not process metals just because we examined the gaps. I do not description the red and yellow colors seen on the screen. I repeat this, the width of the all-colored area that you see as space and room. It has surgery extending towards the back. This is a hollow room. Let's move on the hours count. Yes, when we open our data here, there are two gaps. Yeah, again, a good shot. The 0 point is stacked at the 0 point on the bar you see on the left. Immediately, we bind our cursors over the blue. We look at the scala, which shows the signal strength on the left. Our scala has been extended from 0 to 02. So what can we understand from her? Instead of empty room, we see a room with no ceiling but with side walls. Because the signal on the left is very low. It might be a superficial tomb, not a room or a building. Pulling into the other second space. The signal strength is slightly higher than other gap, but not enough. This place gives you the same impressions as the rest. Signal strength is too low. It is insoluble to headroom, tunnel, shelter. It has an appearance of a structure without roof, a ceiling formed by walls from the top. Where we understand, this is very clear that it does not extend downward from the signal strength. You see them? The interior is also more depth, with smaller dings in the both blue. We open up another data. Yes, our data is displayed. First of all, I move my screen to the shading area. I brought it to location. Location, there is a point I want you to pay attention to. 0 point on the left side at the bottom. I think there was a position error while making the check, or an excessive magnetic field, or we scanned very close. So this shot is a wrong shot and it doesn't give you the right information. Here's where the operator made a mistake. He can't adjust the distance. As we have described in the many projects tutorials in our video, the area where I'm going to scan should be nearest 5 meters. Ideal is 15 or 30 meters. If we get too close to the target, it will disperse the signal strength as we walk bigger than the target, and it will look because there is a small gap or metal. The mistake method is due a very close look at the target and scanning. The distance error has been made here. The target has been scanned very closely. Let's open and examine another data. I think it's probably taken by the same operator. He made this same shot again. They made the same mistake again. Look at the bar on the left again, the butt of the 0 point. This bar is also T-link, and we see the level. The device is held very close to the target. 2 meters, 85 centimeters. In fact, we explain this a lot in our manuals and tutorial videos. If you follow our training videos and read the user manuals in detail, you will not make mistakes. This data can in no way give us an accurate account. Let's move on to another yield. This data contains an operator error. The bar on the left side is again under 0. Here again the distance from the reservation. We are opening another data. Our balance line is the middle. Yes, this check is a correct shot. The shotting was very precise and accurate. There are very small gaps that I am examining gaps in the method area. Target 9 meters, 75 centimeters away. Yes, this is a spacebar scala. When we look at it can easily understand that a space. But this is not a room or tunnel. It totally resembles a hole. It might be a ventilation shaft or separately drilled into the white hole. I think it's a very small diameter, 10 centimeters in diameter. It is just a hole, room and not tunnel. I gap in other blue. I can't say it's inside the room and tunnel. This is a small hole again. We have a blue on the right side of when we come down to half signal strength. These areas are holes formed on the ground. There is air inside. Let's move on to another yield. This shot as a thermal scan. When the error is still shutting, the bar on the left is again at the bottom of 0. The thermal sensor should be used for slim area, water-covered area, snow in the water source. I can easily see that this floor is rocky. The jaundiced you see her evident in the streets containing iron. Because the operator was scanning a rocky area on an non-wet surface. The thermal imager failed and prevent you from performing an accurate analysis. It's because the magnetic and thermal options are not done correctly. There was an error in this check. The 0 point is at the bottom and the other numbers continue. Be increased towards the top. I think there's a position error here too. Not that other shots have been made incorrectly, except for this first faded data. I think it will help you to tell you about the wrong as well as the right. Look, we say don't do this. Actually, it is accurate and successful field, but is difficult to reach the result because the shooting was not done correctly. I repeat, position error has been made here. Here again, an error has accurate. Not that a very blurry and unclear shot has taken place. Scanned a large area. Accurate information cannot be obtained if shooting is so much a large area. So don't shot this wide. Specify and area and capture the area. Be very careful with your handling position. Now, let's open the so-called thermal tool. Our 0 point is the middle, as you can see on the left. Good quality and smooth shooting. However, again a very large area scanned. We do not recommend this to you. We can get healthier image with shorter and more efficient scans. We can say that this is a large floor. We can say there are no gaps. As you can see, I am not going down from the 0 point. Look, there's blues on the right. Here is very a low zero. We can't count. Displays a gap. It might have opened and closed immediately. It has a small depth. Could be a loose ground. There might be small landslides. We consider it to be a rocky, wet ground. I am opening up our other data. As you can see here, a mistake was made when shooting. These mistakes are made frequently. It is actually quite used to use our Proton Elıc device. I recommend you to watch our training videos and read our user manuals. We need to work on the land often. We need to figure out how to use the device in the right position. It is a wrong check, but I will tell you what I said. Here is a spirit space. You can easily understand that there is a tunnel here. Here the operator has scanned about 591 meters away from himself. The error in the grip position make you question the reality of this data. Let's examine our other data. Again, there is a mistake often made by our customers. Our result point is still very low. They try to scan a far away target again. He shot 400 yards away. He took the same place but looked at the target from a different place. Again, there is a mistake in the grip position. Here we have understand that we should not stay too close to the target. Our distance from the ideal target should be between 15 and 30 meters. Let's watch our grip position. Let's fix ourselves before we start the grip. We need to perform a scan on the ground with a thermal damper. This is a mistake. We need to scan the soil with a magnetic sensor. Thank you for watching use at a Proton Elıc Doktrin training. Continue to follow use. Goodbye.